Hello everyone, and welcome back to part 11 of the GT improvement class. Today we're going to work on adding and subtracting mixed numbers. So hope you've had your coffee and you are ready to get to work. Before we start our adding, subtracting mixed numbers, let's do a quick review of what we did with improper and mixed numbers. So I have some problems here for you to work on. The first three you're going to change to improper fractions, and then the other three you're going to change to mixed numbers and simplify if possible. All right, so go ahead, pause the video and get started on that, and then I'll come right back with the answers. All right, so here are your answers. For number 1 on this side, you should have gotten 16/3. I want to point out with this one, what you could have done rather than simplifying after you've done your improper fraction is you could have simplified this fraction here from the get-go. So you could have reduced 3/9 to 1/3 and then worked it out that way. But if you didn't, that's fine. You would still have gotten 48/9, which is simplified to 16/3. For number 2, you should have gotten 62/15. For number 3, 17/8. For number 1 on this side, it would have been 2 2/5. 5 can go into 12 2 times, that's 10. So there's 2 left over. Denominator stays the same. For 9/7, 7 can go into 9 1 time, that's 7. So there's a difference of 2, and denominator stays the same. And this one, 12/4. Well, remember, this bar just means division, so 4 can go into 12 3 times. There's nothing left over, so it's just the whole number of 3. All right, let's go into adding and subtracting mixed numbers. Okay, so when we're adding and subtracting mixed numbers, I'm just going to jump straight into when you have unlike denominators. When you have like denominators, the process is exactly the same. The denominator stays the same, and then you would add the tops, and then you would add your whole numbers. So let me just do a real quick example of that. So if you had 3 1/5 plus 2 2/5, you would add your whole numbers. So 3 plus 2 is 5. The denominator, the common denominator here, is going to be the denominator in your answer. And then you would just add the tops, so that would be 3. So 5 3/5. Let's talk about when you have unlike denominators. Now there are 2 ways of doing this. There's stacking, or there's the improper fraction way. So let's work with this example here. 1 2/5 plus 2 1/9. If I were to work this the stacking way, let me show you how I would set this up. It would be 1 2/5 plus 2 1/9. I've simply stacked my fractions on top of each other. Now, you have unlike denominators here, so you're going to need a common denominator, just like regular if you were adding and subtracting regular fractions. So what I'm going to do over on the side here is I'm going to give myself a new fraction to work with using my common denominator, which in this case would be 45. Okay, now I've got to change my tops. So to change 5 to 45, it was times 9. So I got to multiply 2 by 9, which is 18. And then to change 9 to 45, we multiply by 5. So I got to do the same thing to the top. So now I have a common denominator. So that is going to be the denominator in my answer. I'm simply going to add my tops, which would be 23. And now I'm going to add my whole numbers. 1 plus 2 is 3. So my answer is 3 23/45. And this number cannot be reduced, so we're done. Okay, so that's the stacking way. Let's talk about the improper way. So the improper way, what you would do is you would change each of these mixed numbers into improper fractions. So go ahead and set that up. Go ahead, and I'm going to do it quietly on my paper. So you should have gotten 7/5 plus 19 over 9. Okay, so now we have improper fractions. We still need a common denominator in order to add these two fractions. So I'm going to set it up with a new problem on the bottom using my common denominator, which again is going to be the 45. And then same process, times 9 times 9 times 5 times 5. So then I end up with 63 over 95. Now you can see how these numbers are starting to get a little big, and bigger numbers are usually a little bit more annoying to work with. It won't always be like this. It just happened to with this particular set of mixed numbers. But you know, sometimes you don't end up seeing that it's going to be annoying until you're actually there. So now what we would do is add our tops. 63 plus 45, I'm just going to do this, 95, excuse me, I'm going to do this off to the side. So 158. All right, now I still need to change this back into a mixed number, or most likely I will need to. So I need to figure out how many times 45 can go into 158. Well, 45 times 2 is 90, plus another 45, that would be 135, so that's going to be good. So 158 over 45 equals, can go in 3 times. So we said that's 135. 158 minus 135. It's going to be 23 left over, and denominator stays the same. So either way will get you the same answer. But you can see we had way less steps in this process versus this process. All right, so again, it's up to you, but I really would strongly suggest the stacking way for most problems. I just feel like it's faster and time is of the essence on the AFCT. Okay, let's do another one. 3 2/3 plus 5 7/10. All right, let's do both ways just so we can practice both ways, so we can see what it would look like either way. So I'm going to do the stacking version over here. And then the improper version over here. All right, so you see if you can work these out on your own, and then I will show you the answer in a second. Okay, so for the stacking way, let's start with that one first. Common denominator here is going to be 30, so I'm just going to change my fractions. Okay, let's talk about this situation here. We got our common denominator, we changed our tops, 20 plus 21 is 41. Interesting, we have an improper fraction as part of our mixed number. Please don't freak out. Remember, an improper fraction simply means you have more than one. So all we need to do is just change this to a mixed number, and then whatever the whole number is there, we're just going to add the whole number to this whole number here and keep the fraction. So let me show you what that means. So 41 over 30. 30 can go into 41 one time. There's 11 left over. Denominator stays the same. So now all I'm going to do is add my whole number here to this whole number. 8 plus 1 is 9. And the fraction stays the same. If you ever added your fractions in the stacking method, this is kind of the one drawback that people don't like with the stacking method, is this when they get an improper fraction as part of their mixed number. But please don't freak out. All you have to do is real quick change it to a mixed number, and then whatever the whole is here, add it to the whole here, and then you keep the fraction. Okay? Let's try the other way. So 30 again is the the common denominator. So I'm going to change my fractions around real quick. To do some math off to the side, because I don't know 57 times 3 in my head. All right, so we end up with 110 over 30 plus 171 over 30. Kind of annoying numbers, but not terrible. So this would work out to be 281 over 30. Now, just to make sure I don't make any silly mistakes, I'm just going to set this up in my long division setup already, just to keep myself organized. So 30 can go into 28. Let's see, 8, I'm gonna say 9. Well, 3 times 9 is 270, so I'm gonna go with that. So that'll be 9 times. So 281 over 30 equals 9, so that's 270. So minus 270, that'd be 1, 1, so 11 left over. Denominator stays the same. All right, so again, you can see the difference in the number of steps for these kinds of problems, okay? All right, let's do another one and see if you can work it out on your own. All right, so go ahead and set it up however you choose, either the stacking way or the improper fraction way, and pause your video and we'll come back and go over the answer. All right, so here's the worked out answers for number 2. So for the stacking way, we had a common denominator of 15. So when you change your fractions around, you should have ended up with 3 and 16/15. But since we have to change this improper to a mixed number, that went to 1 and 1/15, so I simply added the 3 and the 1 to get 4 and 1/15. If you did it the improper way, still same common denominator, should have ended up with 25 over 15 plus 36 over 15. That got you 61 over 15. 15 goes into 61 4 times with 1 left over. Denominator stays the same. Okay? All right, let's do some more practice. But let's do some subtraction. Subtraction, still need a common denominator, so go ahead and work out numbers 3 and 4 on your own. Go ahead and pause your video and I'll come back with the answers, all right? All right, so here are your answers for 3 and 4. Oops, sorry about the noise in the background. That's my dishwasher. All right, for number 3, you should have gotten common denominator of 12. Then when you change your fractions around, it's 8 over 12 minus 3 over 12, which is 5 over 12, and then 6 minus 4 is 2. So that should have been your answer. And you would have gotten the exact same answer if you did it the improper way. Notice again, a bit more steps here, but you still would have gotten there eventually. Number 4 should have gotten 2 and 2/15. And same thing for the improper way. 2 and 2/15. Okay, so hopefully you can see that most times the improper way is, the mixed number way of stacking is going to be more time effective than this improper way. Okay, it just generally requires a little bit more side work. All right, okay, there's another type of situation that we need to talk about. For this one, the stacking way sometimes freaks people out, but it's really not that bad. Please don't get too confused. Easier said than done, I know. All right, let's talk about when you have a fraction like this. Now I want you to notice something. 3 and 1/6 minus 1 and 1/4. if you had two pizzas, one that was cut into fourths and the other one was cut into sixths, you can see that a fourth is a little bit larger than a sixth. So in this case, we're going to be taking a fraction away from a bigger fraction away from a smaller fraction. And remember, when you take a bigger number away from a smaller number, you can't usually do that without borrowing. So you're going to run into the problem, not a problem, but the added technique of learning to borrow working with fractions, okay? So let me just show you and just listen, okay? So 3 1/6, I'm gonna set this up with my stacking, minus 1 1/4. This whole process is still the same. Still need a common denominator, which I'm gonna use 12. So times 3 times 3 times 2 times 2. All right. So now you have 2 twelfths minus 3 twelfths. Now I know my denominator is going to be 12, but I can't take away 3 from 2. So just like when we're working with whole numbers, we have to borrow. Now, here's where it gets a little tricky. So what we're going to do is we are going to borrow from this whole number here. Okay, we are going to cross it out just like we do in regular borrowing, and we're going to change it to one less. We're going to change it to a 2. Now, the only difference is you don't give this number here, you don't give it 10 like you would normally do when you're working with whole numbers. In this case, what you have to do is you have to give it the amount of pieces that is in our whole, which in this case is 12. So what you're going to do is you're going to borrow a whole piece which has 12 little pieces in it, and you're going to give that to the 2. 2 plus 12 is 14. Now I can do 14 minus 3, which is 11, and 2 minus 1 is 1. The key with borrowing with fractions, the only difference than it is from regular numbers is when you give the fraction piece your whole, you're not giving it 10, you're giving it however many pieces are in your whole, which is whatever your common denominator is, okay? So, I hope that didn't confuse you too much. Let me show you what this would look like with the improper way. So we have 3 1/6, so that would be 19 over 6 minus 4, 5 over 4. All right, common denominator is 12 times 3 times 3 times 2 times 2. Now, you can see that in this case, if it's an improper, it makes it a little bit easier because you don't have to go through the motions of borrowing. But once you get this, it's really not that difficult. It's just one little extra step. But if you prefer the improper way, you can absolutely do it. If you run into a problem where you have to borrow and you're like, ooh, I don't want to do it the stacking way, then of course, default to the improper if that makes you feel more confident, okay? So the answer would be 38 minus 15 is 23 over 12. 12 goes into 23 once with 11 left over. Denominator stays the same. Okay, so up to you. All right, now you have the how-to-dos with the borrowing situation of stacking. This one also requires borrowing. I challenge you to set it up in the stacking way and see if you can get the process. But if not, if you're like, I don't get it at all, then of course you can absolutely revert to the improper way. But unless you have that good fraction sense, you may not know when the borrowing is going to have to take place. So I still would encourage you to understand both methods, okay? So go ahead and do number 6 on your own and I'll come back with the answer. I set this up in the stacking way, and I just kind of paused before I got to the actual borrowing procedure of it. But when you got this far, you should have ended up with a common denominator of 15, and then you should have been left with 5 minus 6. So we can't do that. So we are going to borrow from the 2. That becomes a 1. And I want you to think about how many pieces are in your whole. When you look at this fraction, it would be 15. So 15 is what we're going to add to the numerator. So that's 20. We can do 20 minus 6 now, which is 14. And then for this part, it would be 1 minus, well, there's no whole number here to subtract, so it would just be 1 minus 0, which is 1. All right. And then if you would have done the improper way, you should have ended up with these improper fractions, which got you 29/15, which would become 1 and 14/15. So same answer. Okay. I hope this has been helpful. I promise multiplying and dividing mixed numbers is going to be much easier. It's always the adding and subtracting that's harder with fractions, all right? But hang in there, you're doing great. If you have any questions about anything, feel free to write a comment and I will get to answering that as you need, all right? Take care and have a wonderful rest of your day.